last week? This is one of them. Remember anything we talked about last week? Earth is just the right place at the right time. All right. So, in addition to Earth being the right place at the right time, we're talking about all the glue that holds the universe together. We're talking about all of the fundamental forces of nature. And it's not just that Earth is the right place at the right time, it's all the things that underlie all of those things. It's not just that gravity, it's not just that Earth is a certain distance away from the sun, which is true. It's also that gravity itself is the right strength that it needs to be, or otherwise the universe doesn't work. So we talked about last week how gravity is so finely tuned that if you stretched a ruler across the entire universe, the force of gravity could only exist in 1 inch of that space. So if you had to make that distance, if you had to get in a spaceship and travel across the universe, it's nothing that could be done inside of a single lifetime. The universe is billions of light years across. And so if you got in a spaceship and you had to choose the force of gravity, it would be like you getting in a spaceship traveling across the universe, which would take billions of lifetimes, and then you would have to pick 1 inch inside of that known space for gravity to occur. If gravity is just a tiny bit stronger, the whole universe collapses on itself. If gravity is just a tiny bit weaker, the whole universe expands so rapidly there's nothing stable about it, and everybody dies. Everybody dies either way. 1 inch, okay? We talked about, last week we were talking about the mass of the universe. So it's not only that the fundamental forces of nature are balanced, it's that the total amount of stuff in the universe is also balanced against this. So this is the measure of all of the stuff that's in the universe. And if you look at these two lines, the red line is if there's just a tiny amount extra stuff in the universe. So if we go out there and we add a couple extra galaxies and we push it just a smidgen over, you can see everything collapses back on itself. So the universe expands temporarily, and then there's so much stuff in there, the gravity between those things starts to pull it all back together. It overwhelms the other forces and it crunches it back. Or it expands so rapidly that there's no stability among the universe. So there's if the universe expands too rapidly, then there's no spinning of all of these things. There's no spinning of the galaxies. There's no spinning of orbits around anything. There's no stability in any of those things. So you would have individual stars, you would have individual rocks that would float around them, but there wouldn't be anything that could sustain life. Okay? All right. So this is the cosmological constant. This is balanced in the universe to 1 part in 10 to the 120th power. So this is one of the forces that is balanced against gravity. So gravity is not only balanced against electromagnetism, gravity is not only balanced against the strong nuclear force, the stuff that's holding all the atoms together, it's also balanced against the amount of stuff in the universe and the rate that those things are flying apart from each other. Okay? So if this is the same type of story. If gravity versus the cosmological constant, the rate at which all of the stuff is flying away from each other, if these things are not precisely balanced, then you get the same story. You get the universe which flies apart too quickly and there's no stability in it, or you get the universe where it collapses on itself and everything dies again. Okay. So this is kind of where we ended last week. So Sean Coffey sent me a really cool photo of this. Let me pull. Oh, don't you love it when your kids take hundreds of photos on your phone? Is that only me, or does that happen to y'all too? And they always say, it wasn't me. Okay. So this is the photo that Sean sent me last week after the lesson. We were talking about how uniform the night sky is, and all of these things are a lot easier to see on your phone. But if you look across all of these things, like there's little pieces where there's slightly more stars and slightly less stars, but on the whole thing is pretty uniform. Okay, you go out in the night sky, you don't see these giant gaping holes where there's nothing in them, and then you don't see these immense. There's just trillions of stars inside a tiny little bit. It's all uniform from one side of it to the other. George, did you have a comment?
I have a hypothetical question.
Okay.
You don't have to have an answer for it.
Okay.
I'm just going to throw it out. Something we can all think about, I think. We've seen pictures and videos of the astronauts on the moon,
Mm-hmm.
and they can jump and go all kind of things up and down. And really they have a lot of fun doing, high jumps and all that because the gravity is less. And they only stay there several days. Suppose life could exist on Jupiter as us. And we know we live on the outside of the Earth, and gravity holds us there. So we're walking around with our feet on the Earth, pointing outward. And gravity's working on us. Suppose we stayed there several years. What would happen to our bodies?
On Jupiter?
Yes, sir.
Oh,
or anything with more gravity.
Anything with more gravity. So your body's just not built for it. So one of the consequences would be that your bones would start cracking on you. So imagine, so the gravity on the moon's like a third, and that's why they can jump and do all those neat things. Gravity on Jupiter, I don't know what it is. It's immensely stronger than what it is on Earth. So imagine like walking around with like a 300-pound weight vest on your or a set of barbells or dumbbells. If you put that kind of strain on your body, like all of your bones would have to be significantly thicker in order to support the weight of those things. So that's one consequence. I don't know. I'm sure it's not good. I mean, it might be. You might have to get super strong ankles and knees at that point. Yeah, it's yes.
I mean, if you think about what you just pointed out, 1 part in 10 to the 120, that just screams against chance.
It does scream against chance. Yeah, one part. Sorry, could you grab them?
And the other part is the picture you showed of the cosmos. It's hard we can't see that here because of all the background lighting, but if you go to somewhere where you're probably 100, 150 miles from the nearest city with no background light, you can see those types of views. First time I saw something like that was in the middle of nowhere, California.
Mm-hmm.
And it was just, I probably looked at it for about an hour. I was awestruck by it. And if you ever go anywhere where you're in the middle of nowhere, take the time at night, especially if it's a clear night, to look up and you'll see a picture just like what's on the wall.
Yeah, it is absolutely amazing. We went to Arches National Park and we stayed up real late one night and we got to see the Milky Way across the sky, and it is just absolutely fantastic. I can't recommend it enough if you get a chance to do it.
At 40,000 feet.
At 40,000 feet?
With just a canopy and view it.
I can imagine. Yeah.
So it's just an inkling of what the astronauts see.
Right? Oh, I lost it again. Okay. Come on. I love technology. Okay, so we talked about last week how these are all different views of this. We're looking at how uniform the stuff is out there. So not only we got the right amount of stuff in the universe, like we don't have too much or too little. We have the same Goldilocks problem with just the amount of stuff that's in there. We're looking at how uniform all of this stuff is distributed across the night sky. So the left one is the most zoomed in that we have, where each one of those swirling things is a galaxy. And then we back out a little bit, and you can see some of the closer stars. And then if you back out again, as far as you can go, each one of these each little dot in here is its own little galaxy. And so it's not just this stuff is just uniform in our local neck of the woods. This stuff is uniform across the entire spectrum of the universe, okay? So, cool. Why do we care, okay? If this is really cool for me, I think this is really interesting. You can actually measure how uniform all of this stuff is distributed across the universe. So if you take a flat surface like this table and you draw a triangle on it, okay, every angle adds up to 180 degrees, okay? It's just basic geometry, okay? If you take the same triangle and you overlay it onto a ball, like the middle one, okay, all of those angles will add up to slightly more than 180 degrees because the sphere of the ball will bend the lines out a little bit, and they will actually bend this way as well. And you'll add up the angles again, and you'll get all of the angles will be slightly more than 180 degrees, okay? And there's the inverse of this. It's called a saddle. If you put a triangle on one of those things, all the angles will add up slightly less than 180 degrees, okay? So what you can do with all of this is you can use this thing of geometry that works with triangles on your table. It also works in the universe at large. So you can take those and you can measure how flat the universe is, okay? So if you look at these are images of gravity causing space-time to bend, okay? So if you look at the yellow one would be like a star, and space is this enormous blanket that's out there, okay? Or you could think of it like a trampoline, this enormous stretched piece of canvas that's out there. And you put something in it, and gravity causes those things to bend around it, okay? And so the little ones could be a planet or a moon, or here's the exact same thing with our Earth and our moon, okay? That's what happens when gravity gets a hold of these things, okay? So what you do with the triangle bit is Earth becomes one part of the triangle, and then you can measure you can pick two stars out there. They have to be really special types of stars, but you can actually get them where, because of their certain brightness qualities, you can measure the angles not only between us and them, but between them and themselves, okay? And if you do that, you find out that the universe is flat to 1 part in 10 to the 62nd power. So the universe is not a sphere. It's not a ball. The universe is not inverted like a saddle. The universe itself is a very thick pancake that's a very large disk out there as far as you can possibly see, okay? So the reason that this is interesting is because this is the most hard state to achieve, okay? So think about if you took a cosmic bowling ball, okay, and you had to start at the beginning of time, and you had to roll the bowling ball from one side of the universe to the other, okay? The tendency when I play bowling is that the ball will go in one gutter or it'll go in the other gutter. You know, I'm not very good at it. I'm sure most of you play bowling. You're much better than I am. But the hard part is keeping it down the middle, okay? It's the exact same way with the flatness of the universe. The hard part is keeping it flat, because any variations and how uniform this stuff is spread out there it gets amplified the longer and longer and longer that time goes on, okay? So like when you're starting with the bowling ball, you can start at the beginning and it may look like it's going to go straight for a little while, and then at the end of it, it may curve off one way or it may curve off the other, okay? The same type thing happens with our universe. Everything is getting slightly more disorganized the longer that we go on, okay? It may have started in an incredibly ordered pattern, but the laws of physics, the laws of thermodynamics, they're necessitating that there's more disorder as we go along, okay? If you think about this from the flatness of the universe, it's much easier to get a universe that turns into a ball or a universe that turns into a saddle than it is to get a universe that is incredibly flat like a pancake. But that's exactly what we have. So 1 part to 10 to the 62nd power. That means if I let you choose one atom in the universe, not just one planet, one star, one atom, one piece of anything. Like there's billions of atoms inside you and I. There's billions inside this room. If I let you choose one atom in the entire universe, that's the degree of precision that we're talking about. That's 1 part in 10 to the 62nd power. So like one of the other amazing things about like apologetics that you learn about is you learn that the chance of Jesus fulfilling all of the prophecies in the Old Testament is the same as if you filled the state of Texas with silver dollars. If you filled the state of Texas silver dollars 2 feet thick, and then you set somebody out on a journey and said, pick one of them, that's the random chance of you being able to fulfill all the prophecies that Jesus fulfilled in the Old Testament. It's impossible, okay? Now we're not just talking about the state of Texas and silver dollars. I'm telling you, you could pick one atom in the universe. That's how remote the chance is that the universe stays flat. It's just unbelievable precision out there. Okay. Yeah, this is what we talked about just a second ago. This is saying that the initial conditions. So remember how I talked about everything starts in a more ordered position than it is now, and everything is slowly getting worse, okay? The stars are slowly burning through their fuel. All of this stuff is slowly getting more disorganized as we go throughout of it. The physicist Roger Penrose, he is a Nobel laureate in physics. He said that the odds of the universe starting as organized as it had to be to get us where we are now, with the flatness of the universe and all of those things, is 1 part in 10 to the 10th to the 123rd power. So if you Google that, Google will say that it can't display the number. It will tell you basically it's infinity, because it's a 10 with a 1.23 trillion zeros behind it. It's a number with 1.23 trillion zeros behind it. It's a number so big that if you wrote it on a piece of paper, the pieces of paper would be like this thick, because you can't display that many zeros on a single piece of paper. You have to get like reams and reams and reams to get that many zeros. It's just incredibly immense powers of just initial orderness that's in the universe. All right. Okay. How do we explain all this? What are my three options? How did this all happen? We got really lucky. We got really lucky. It was chance, you know? Okay? That's the first option. It was by design. That's the second option. There is a third option. It's always been that way. Okay? Another way to say this is there may have been no other option. Is what they will tell you. Okay? This is the three options. Okay? Physical necessity. It must have been this way. There was no other options for gravity. There was no other options for the size of the universe. There was no other options for the mass of the protons and the electrons. There was no other options for any of those things. The only way that any of it works is like there can only be one option for all of these things. Okay? So we know from computer simulations of all of this stuff that the life permitting range of all of these variables is incredibly small. So let's say the physicist is right. There's only one value for gravity that it ever could have been, and gravity had to be that way because there's just nothing other. There is no other option. Why is the amount of stuff in our universe the amount that it is? If you take the fact that, okay, maybe gravity has to be that strong, and maybe the electron has to be that small and have that exact charge. If that's true, which, we don't have any other hypothetical universes that we can go visit to look and see if there's any other forces of gravity on those. So maybe that is true. What isn't true is that the amount of stuff in our universe that depends on gravity, all of that stuff, there's no particular reason why we have the amount of stuff in our universe that we do. There's no particular reason that the amount of stuff in our universe is distributed so evenly that it makes everything flat, and it makes it where we can look up in the night sky and you can see all of this stuff. Okay? So even if you accept that gravity had to be the strength that it had to be, as improbable as that is, then it's impossible to accept the fact, for me, that all of the stuff out there is placed exactly where it needs to be so that all of the universe becomes exactly how it has to be. Okay? So physical necessity breaks down. The other thing about it is there is no chance that the universe happened the way that it did. Like when we were talking about the astrophysics of our own planet, and we're talking about, there's a 1% chance that it ends up the right distance away from our star. Okay, it's a really low chance, but it's possible. If you give it enough chances, those things can happen. Okay? There is no chance that the universe ends up completely flat. It's just like you can flip a coin 10 times in a row, there's a chance you will get 10 heads. You can flip a coin 20 times in a row, there is a chance you'll get 20 heads. It's incredibly small. You cannot flip a coin 200 times in a row and get all heads. It does not work. The math becomes so impossible at that point. You can flip coins for eternity, billions of years, and it never happens. Okay? So small chances are, you can mess with those, and those can be possible. When you get to the order of magnitude that we're talking about with the flatness of the universe, the amount of stuff that's in the universe, the charges for all of the atoms themselves, those have to be designed. They cannot be random chance. They have to be part of a grand creator's initial design. Nothing else works. Okay? So, hang on 2 seconds, Juan.
anyway, I have a comment. Just from some of my studies in the past, I mean, it's just for you know, if we look at the law of probability, and I believe the number is correct. I think if you take any law of probability that's less than 1 to 10 to the negative 45th power, for all practical purposes, it cannot exist.
Right.
Even though in theory, mathematically, it can. Any one of those scenarios, even from, creating, amino acids just by random, it's way in the 1 to the 10 to the minus thousands to millions, depending on what scenario you're looking at. So none of those mathematically come even close to the 1 to the 10 to the minus 45. And anything that's less than that can't happen, practically.
Can't happen.
Cannot happen.
That
Yeah.
is exactly right.
And so it's just mind-boggling that we continue to propagate this, in society.
Yeah. So like, if I went out and I bought a lottery ticket and I won the lottery, I won whatever it was, $20 million. And then the week after that, I came back to church and I said I won the lottery a second time. And then the week after that, I came back to church and I won the lottery a third time. You would say, I am cheating. You'd be like, I don't know how Wiggains is doing it, but it's clear he's cheating, All of those things, and you would almost have to be right, because like the chances of those things, never happens. Nobody wins the lottery twice, unless we're talking about a really, really low stakes lottery, These are galactic lotteries. Nobody wins the galactic lottery more than once. Nobody wins the galactic lottery once. That's the whole point. Like Juan said, these probabilities are zero. They are not just like really close to zero. They are infinitesimally close to zero. They should never happen. That's how remote these things are. Okay? So, yes, Angelica, hang on 2 seconds. We'll get you a microphone. George, you want to comment?
I'm going to follow up on what Juan was saying. The atom is made up of 3 basic components, as far as I know.
Mm-hmm.
Electrons floating around it. In the nucleus, there are protons and neutrons. And those are the 3 components. I don't care what kind of atom you talk about. The only difference is the number of those 3 components.
Mm-hmm.
It is so simple. Where is there some atom that has something else that we haven't found yet? Just happened to be there. It's not there. I don't care where we go. Everything we talk about is made of atoms. And they're all so different. The difference is the numbers. Just like somebody working a computer. I'm not a computer person.
Right.
But you have just a few numbers they work with and make all kind of amazing things. And God made all this stuff out of one type of thing, an atom. And he made all those atoms because of the numbers of those 3 things I said, all different.
Yeah, absolutely. So when you start looking into a microscope, you just see immense amounts of complexity everywhere that you go. You see, like you said, you see all of the atoms and all of those things. But when you get down to the most basic level, you see that everything is made up of about the same basic construction, the same basic components. Everything is built from the ground up, okay? So all of the atoms are constructed in just the right way, made out of the exact same components. There's proton, neutrons, and electrons, and you get different amounts of them, but everything is built from the ground up, and then the complexity comes after that. Angelica?
It's interesting talking about probabilities in math. Actually, the fundamental truth of math is that there are truths that cannot be proved. So math actually has it's not flawless like we think. We have proofs, we have axioms, which are truths. We have proofs that define the truths and prove the truth of that equation or whatever the truth needs to be. But deep down, math actually has a small flaw. and that is the truths that exist that we cannot prove.
Like what?
So, oof. So you have, for example, rational numbers and real numbers. You know,
Okay.
if they go, okay, in integers from between 0 and 1,
Yep.
and then, you know, just, or your normal prime number, so 1, 3, 5, blah, 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 blah. So the thing is that you have so many of these numbers, and they can be infinite, but are they infinitely equal to infinite? Is a thing. So when you get deep down into specific little issues in that example, technically speaking, rational numbers may have a greater infinity than prime numbers. So real numbers may have a greater infinity than prime numbers. So for example, those digits between 0 and 1, they could be infinitely more infinite than from 1 up.
So numbers from 1 to 100, there's more integers than there are prime numbers. Is that what you're saying?
So from
But
1
then
to
it-
infinity
Right.
is technically less than 0 to 1. So it's just
Okay.
that's just one small little thing, but the basic thing is that math has a small flaw, that they are just truths in nature we cannot prove.
Okay. Okay.
Intellectually, we cannot prove.
Okay. All right. So, what are the physicists going to tell us? They're going to look at this and they're going to say, I still don't believe in God. Okay? I still don't believe in your fine-tuning argument. You know what they tell us? There's two options that they'll tell you. First one is this one. What about the multiverse? Can someone who's on the younger side please help me out and explain what the multiverse is? You think they're not here? Come on, someone knows what the multiverse is. Oh, we got one right there. What is the multiverse?
Basically, the multiverse is where we are in one plane of a reality, and outside of us there are alternate realities that are like in the same time but have different variations of events. So maybe in our world we have a historical event that has a drastic effect on our society, but in this multiverse, this same event got prevented or changed somehow, and it has a different effect. So the world in the multiverse and the different strains have different outcomes than what we're experiencing.
Yeah, so like one event happens this way in our world, but it didn't happen exactly the same way in another world. And so everything was the same up to that point, and then that choice happened, and then the universe split off. Okay? You want to add to that?
Yeah, it was introduced in some of the Spider-Man movies. So that's an easy concept that's so intertwined because it goes so deep down into a physics level that we really cannot understand. Because then you're stating that, for example, in this reality you have a mom and dad, but in the other reality you never had a mom and dad, you're an orphan.
You were an
But
orphan, right, yeah.
Yeah, and then another reality, it's
You maybe had the dad.
you have dreads. I mean,
I would
Yeah.
look good with dreads, I think. I would take any amount of hair that decided to hang out up here.
One of the I think it was originally introduced in like comic books because the companies didn't want to stick with the same continuity. They wanted to have the liberty to change the story.
Right.
So this idea was brought up because these characters that everyone loved so much the creators and writers wanted to put their own spin on it without getting the backlash from fans.
Yeah, yeah.
And unfortunately, because of the popularity of it, a lot of people in other fields decided, oh, well, this must be a real thing because there were so many possibilities that could have happened in this event or in this thing. There must be other timelines or universes where people chose differently from us. So, like I think the most recent iteration of this would be like Marvel did a TV show called What If. And What If is basically in these mainstream, like in the main MCU universe, what we see in the movies. What if one of these characters chose something different? What would happen? What if we're in a different timeline? What if? So people take this what if concept and apply it to other places where it's supposed to be a fun fictional thing for us to expand upon characters we already love.
Yeah. So what if the spider doesn't bite Peter Parker? What if the spider bites the little girl in the class? Or if it bites, it doesn't bite anybody in that class. It bites somebody from a different class. Hang on one second, Ms. Linda.
Just to mention, this isn't new.
Right.
This is just now being thrown at our kids.
It's just now popularized.
Because I remember back when I was a teenager, there was a show where they jumped from universe to universe through a time portal trying to get back.
Yeah.
And so it's not a new concept. It's like, that's how they explain it. It's like, well, it could have happened millions and millions of times, the universe formed. It's only in our universe that we're aware of it. And how many times could have happened, making it back to a chance thing.
Yeah, absolutely. I think Miss Linda had a comment.
I actually don't have a problem with the multiverse because it's called free will. Because if there weren't the possibility of multiple options, we wouldn't have free will.
Right.
And the Bible says that we do.
Right.
So your choice determines the ultimate outcome. Does that change anything with God? Absolutely not.
Yeah, absolutely.
Because we can't, our brains can't process that anyway. But I want to share two verses. One says, this is Ecclesiastes 3:11. It says, He has made everything appropriate in its time. He has also set eternity in their heart without the possibility that mankind will find out the work which God has done from the beginning to the end. And so what is that work? And that's in Genesis 1:1 that, everybody knows these verses, but it says the earth was without form and void, and darkness was over the face of the deep, and the Spirit of God was hovering over the face of the waters. And so when I'm thinking about the slides that you showed before, it says, and God said, let there be an expanse, which is what you showed, in the midst of the waters, and he set it separate the waters from the waters. And in the expanse, God separated the waters that were under the expanse from the waters that were above the expanse. And it was so. And God called the expanse heaven.
Yeah, absolutely.
Very simple for me.
Right.
Don't know how he did it, but
Yeah.
None of this is a problem.
Yeah. So the physicists are going to tell you that we don't just live in a single universe. There could be a multiverse. There could be trillions and trillions and trillions of universes. And instead of, it happening where everything just, gravity's the right strength in our universe, we have the right amount of stuff, it's the right amount of space between all of those things. If you put trillions of universes together, and we just got lucky. What they're saying is we didn't have one chance to do it. we weren't just playing the lottery once and then that was it. We were playing the lottery a billion times. And eventually, one of these universes had to come to the point where everything worked together. That's the idea between it. It's completely unprovable and untestable. There is no evidence for any of these things to happen. And statistically speaking, if you want to believe that there is a multiverse and there's different chances for all of these things to happen, all of the universes would have to be connected in some way. Okay? So think about if I took a jar and I had 6 marbles in it, 3 red and 3 blue, and I take a blue marble out of it, okay? Your chances of getting a red marble has now increased on the second draw, okay? If I take the marble out and I leave it out, there's now 5. There's 3 red, 2 blue. If I take another blue one out, your chance of getting a red one has increased, okay? That's what we call statistically linked. They're non-independent events. If I take the marbles, put them all back in my jar, I take a blue one out, and then I put it right back in there. My chance of getting a blue marble again is the exact same as it was the first time. It's still 50-50. And if I do that every single time, I take it out and I put it back in, you're rerunning the scenario with the exact same initial conditions. There's no reason why any of these things should end up differently. So if the universes aren't connected in some way where they're not related to each other, they can't impact, they can't affect each other, then all you're doing is you're taking the marble out and you're putting it back in, and the chance of you getting the exact same result is the exact same as it was in the first place. Okay?
Lance.
Where are we at?
I was going to say, concerning all of this, what you were talking about earlier, the fine-tuning of the universe. See, that's the thing. The scientists, they look at it, and they know that they have a problem with the whole evolutionary theory, that it was all by chance. They know that. They know that this reeks of intelligent design. But yet, instead of admitting, okay, this was intelligent design, this was designed, they will come up with various different theories, such as the multiverse theory, to explain that away. Instead of admitting, okay, God exists and he designed all of this.
Yeah, absolutely. Here's the second option. Oh, man. We are running out of time. So here's the other thing. If you have a multiverse, you have to have some machine that generates a multiverse, okay? The problem with the machine that generates multiple universes is a machine can only make things that are simpler than itself to begin with. A machine can't create things that are more complex than itself. So if you have a machine, let's say you believe in the multiverse, you have a machine that generates universes for it, the fine-tuning that's required to create a machine that creates multiverses is exponentially larger than any of these other things we're talking about. You don't get around the problem of the fine-tuning. You've just amplified the fine-tuning because you now created something that creates fine-tuning itself, okay? So here's the other option. The other option is you live in a simulation. Okay? You live inside the matrix. Okay? We can simulate all of the hypothetical variables. We can run computer simulations, and it shows what happens when we change gravity. It shows what happens when we tweak the distance the Earth is from the sun. We can run all of these things. I've seen simulations of them happening. They speed it up and they show how these stars form together. What if the simulation is really complex? What if we can't just simulate how all of these elements work with each other? What if we've simulated down to the point where we've simulated how atoms get together and the computer is just running, but it's simulating people? It's not just simulating all these really big events. It's now gotten to the point where the computer is so complex that it's now simulating what people are doing inside of it. And now everything is being so completely simulated that now we we live inside the matrix and we don't even know it. I'm telling you, these are the real things that people talk about as specific options to say that fine-tuning doesn't exist. The really funny thing about living in the matrix is that if you're living in a simulation, how do you know that the people who created that simulation aren't also living in a simulation? Like, it never ends. So, that's the thing. I'll do these real quick. Wherever physicists look, they see examples of fine-tuning. Stephen Hawking. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features of the universe, the special features the universe has, he is hiding his head in the sand. These special features are surprising and unlikely. All right. Thank you for all your comments. I appreciated it today.